You're not already. All right, let's get Unreal opened up in a second. Uh, Tropical. Yo. Hello, everybody. Glasses, as always. Okay, I'll take this off. Let's get started with Unreal Engine. So, if you haven't already, go ahead and open it up, and I'll transfer my camera back over. Okay. All right. Let's get this. Let's get this going. So library, um, launch, right? So we sort of went over the basics of Unreal programming last time with Blueprint classes and their components and how that all works together. um, go. Just
And then getting confused about inputs,
inputs. I don't remember exactly what you're referring to
which
actually.
I actually spent some time figuring out how they operate. Um, it's not that different. It's just you have to like think about it differently.
What specifically? What inputs are you referring to?
The deprecated, the new
Oh,
enhanced
the input
input.
system. Yeah, I got you.
Yeah.
Yeah,
Also,
that was.
are you using Unreal 5.3? Are you still on 5.2?
I'm. It doesn't matter for our purposes, but
Okay, cool.
I'm in 5.3. I updated.
And also,
Yeah,
you're streaming Discord, not Unreal.
I am aware. I'm adjusting
Okay, cool.
stuff on my other monitor. Sorry about that. Okay.
You're good.
Unreal is opening up. I'm gonna make a new blank project with Blueprint as a setting, scalable maximum. It doesn't really matter. And go ahead and there we go. Okay. All right. Here we go. Unreal. Wonderful. Ooh, we have some new. Ooh, there's some new buttons down here. I don't remember these being down there. That's cool. Traces, channels. Ooh, all right. So, you've launched Unreal Engine. You should be looking at something like this. Last time that we were here, we covered moving around the engine, um, different kind of features of the engine, uh, and we also made a blueprint class together that was an airplane. We flew the airplane through a ring object. We had that ring object detect if another object passed through it, assume that that other object was an airplane, and if it was an airplane, call a function on the airplane that said, "Yay, you've gained a point," something like that. So let's go ahead and get our project set up. I'm going to still use those same input settings. Maybe this time we'll talk about the character blueprint. I think that that might be a healthier direction to go in. We can also talk a little bit about materials. Yeah, yeah, materials as well. Oh, I should. Can you close my door, Rob? Sure. Thank you. Appreciate it, man. All right. Sorry. So, yeah, let's go ahead and make a new blueprint class. So I'm gonna just kind of get started here with a blueprint class, and I'm going to make this a. Uh, we'll do a character component this time. I want you guys to get familiar with what a character is, because there's a very good chance that if you're making a game, you're going to be making a game that is a first person shooter or a first person something game, you know, third person potentially, but it's got a humanoid character or just some sort of character that can walk around. So this class comes with all of that functionality built in. It's a very powerful class. Um, our character. Great. So if I open this up on my other monitor, or just drag it over, we see that our character is this capsule collision right here. And the capsule collision has a bunch of physics that are being driven by this character movement component. The character movement component, like it says over here, handles logic for the various associated character movements, things like accelerating, decelerating, sliding down hills, anything that would make Mario move around is handled by character movement. So it's a very important class. We can visualize it a little bit better, but I think the best thing that we can do for now is maybe if we click on the arrow. Um, we can't click on it, and I think that's because some of this is inherited. Yeah, I'm pretty sure everything but it's kind of odd. Well, what we can do is over here we can change the visibility to not be hidden in game of the capsule. So now, back in our game, if we drag this guy in, there he is. When we hit play, we'll be able to see him. So if I do play right now, I'm not going to possess him, but I can see him. There he is over here. I don't know why it spawned me so far away. It spawned me at 0, 0. But here is our capsule. You can actually see it during gameplay. Otherwise, it would have been completely invisible. Cool. Let's delete a thing or two over here. Let's see. We've got a player start. That's why it spawned me over there, because there's a player start class. I can go ahead and move that over yonder, a little bit closer to us. So this is the player spawn. So now if I hit play, it'll spawn me right next to the capsule. There we go. Cool. Yeah, let's go ahead and delete this, and now it'll just spawn me where I currently am. That's better. We can also go into the project settings like we did last time and switch out the gameplay related classes, the gameplay framework classes. So over here under game mode base, we can make our own game mode and our own pawn class and our own etc, etc. So under content, game mode, we can call this my game mode. Save it. The default pawn is going to be the character that we just made. What did we name him? We named him our character. So if I go over here, the default pawn can be our character. HUD, everything else, I'll keep it the same for now. Yeah, let's go back. Now if I hit play, it spawns me, and I'm possessing the character class. Great, great. So we're actually possessing the character class. WASD is doing nothing right now. I can't look around. Not optimal, not optimal. Let's take a look at what we can do to make this work well for first person. So
I had a question. Real quick.
sure, what's up?
When you're possessing a character, how do you release your mouse?
When I'm possessing a character, I do Shift F1. Shift F1.
Okay.
See at the top left, it says Shift F1 for mouse cursor.
Oh,
Over
I
here.
see that. Yeah.
Whenever you start the game, it gives you that little. It's like click it, Shift F1 to get the cursor back, and then you can go up here and do pause. You can even detach from the player and go back into this like editor mode, reattach the player. So, yeah.
Cool. Thanks.
Yeah, absolutely. A warm reminder, if you're having performance issues, it's this settings button up here, engine scalability. You can turn this down and make things run a little bit faster, by the way, just for anyone wondering. Okay, so now when I hit play, it replaces us in midair with our character, because that's the default game mode, spawns it in, does all the pizzazz for us. Let's add some controls. So, what we're gonna do here is we're gonna do yaw. There's, I believe, yeah, pawn input. This right here should work on mouse Y, or mouse X. Mouse X. Let's see. This should talk to the character component and tell it rotate around with the mouse. Yup. So now when I move my mouse left and right, it lets me rotate left and right. Very nice. What this is doing is it's taking the input from the mouse X, like how much it's moving to the left or right each pixel, and every time our mouse moves, it's adjusting the rotation of the player controller, which is like the soul of our character. And in doing so, this character component is made to read that rotation. In fact, you see how many settings it has over here? It has like 1 billion settings. If we go to general movement, if we go to yaw, I think, or yeah, rotation, there's something here about controller rotation. Yeah, use controller desired rotation. So if true, smoothly rotates the character towards the controller's desired rotation. So the controller is like the soul, and the pawn here, the character pawn, is going to try to hit the rotation that we're aiming for. So if I check that now, and I enter mouse input, it still feels instant, but if I set some limitations in here for rotation speed, yeah, rotation rate on like the y-axis, I think 0 is just infinite. If I set this to 1, I'm sure that this would very slowly rotate me around. Yeah, it feels different. It feels a little bit different. But anyways, all right, enough with fooling around with some of those settings. I just think that they're important to be aware of, just how this is all working. You can also do add controller pitch input. Add controller pitch input. And we'll do mouse Y for this. Mouse Y. Whoop, that's not right. Mouse Y. Here we go. And now we should be able to look up and down. Cool. Oh, it's a little bit inverted. That's cool. We can go ahead and do invert. Is there a setting like that in here? There might be. Invert, nothing. Okay. Y? Doesn't matter. What we can do is we can also multiply this by -1. So if I just do this, multiply by -1, now our vertical look is going to not be inverted. Cool. Hit play. There we go. And now I can look around. Great. Everything feels good using this with my mouse. Let's also add some WASD stuff. So key, W key, W key, right? We can do add movement input. In what direction? Forward, probably. So get forward vector. Well, we want to do get forward vector of the actor. Get actor forward vector. Nice. Compile, save, and now when I press W, nothing happens. Interesting. Perhaps this value is too low. Or perhaps we have simply, yeah, I don't know, let's see. We can try to print a string at the end to make sure that's even receiving our input at all. So compile, save, play, W, it certainly is. There's W coming through. It doesn't like that. That might be just the fact that we're not using an input axis. It kind of typically prefers an input axis. For instance, if I did mouse X and plugged in this axis value here, what this would probably do is, actually we'll do it downstream a bit like that. What this would do is this would give us like Doom controls. Yep, as I drag my mouse back, we're actually shifting we're walking. We're walking forwards and backwards, just a little bit. Or actually, when I shift my mouse left and right, there we go. Right, we're kind of walking forwards in a circle. Left, we're walking backwards in a circle. Cool. That makes sense. I should have been mouse Y for this. That would have given us more Doom-esque controls, like the original Wolfenstein or something. Okay, so yeah, it's the fact that W, when we're pressing it, it only fires off a pulse. It doesn't fire off like a continuous input. So we're gonna go back to the legacy input system real quick. I haven't taken the time to freshen up on it since last time. And we're gonna go to input. And we're going to go under. It's so tempting. It's so tempting to use the old input or the new input, but I don't want to mess around with it just yet. So we'll do axis mappings. We'll call this forward, or we'll call this, yeah, walk, forward, backward. And we'll do the W key, and we will also add the S key for -1. We'll make another axis mapping called walk left, right, and we'll do A is going to be -1, D is going to be 1. Perfect. Back in our character, we can capture these. So axis or walk forward. There we go. Walk forward, backward, like this. There we go. And we can duplicate this and do walk left, right, like so. Bang, bang. And this time we're going to do get right vector of our actor, just like that. And now we have full movement controls. WASD. Everything's working. I can walk anywhere I want to. We are halfway to a successful first-person shooter. Like, this is great. It's working. I'm happy with that. Now, just like with the airplane demonstration, there's also stuff related to like a camera, right? So we can do something like add a spring arm. And the spring arm can live back here. Notice we have a, actually, yeah, I can live there. Notice we have a character mesh component that's not actually, there's nothing there right now. If we had a skeletal mesh like Manifold Man, if we exported him and we plugged him in here to his walk cycle, we can make him walk around. But we're not going to do that right now. Doing programmatic stuff with animations is a whole can of worms, and I don't want to go down that path. So spring arm, gonna rotate that like 45 degrees, give it a bit of a longer probe. Oh, that's not longer, that's just bigger. There we go. Longer, farther away. Put a camera on the end of that. Like so. Very nice. Point that down. Excellent. Give it a field of view of like 110 because I like it when my screen reminds me of Quake or Unreal Tournament. And now, there we go. So cool, we can look around like this. Our vertical axis is no longer under our control, but at least we can look around. That's pretty cool. Nice, nice. Very nice. I'm gonna spend today focusing on like different movement input systems and how we can like that should give us some good ideas of different problems that you might run into. Let's add camera lag. That would be cool. So I'm just gonna go down to where is it? Lag. It's under the spring arm. Sorry, rotation lag. Enable camera lag. That's gonna make it kind of follow us a little bit slowly. And give it a little bit of rotation lag, like just a little bit. Compile, save. Cool. Hit play. Nice. Nice. There we go. Whew. There's a little bit of like bounce to it now. Very cool. We can also make it so that spacebar makes us jump up and down. Let's add an action mapping for jumping. We'll call it jump. And jump will be bound to the spacebar key. Back to the character, can do jump, just like that. And we can make the character jump, because jump is just a property of the character movement. It's like a relatively universal property that we can access and take advantage of. And now we jump. Nice. It's basically a platformer. We're on our way. We're on our way. It's not quite Mario yet with like the somersaulting shenanigans, but it's something. How about we let's do some I'm thinking of like a game that we could design real quick that would have some of the problems that we want to solve and demonstrate. So let's actually turn this into a bit of a shooter. The way I'm going to do this is I'm going to make it so that it's got Roblox style controls. Who's played Roblox before? Anyone? Anyone a big Roblox player?
It's been a while.
That's the respectable answer. I mean, I'll admit I'd give it a try here and there. It's a good game. You know, it's got a lot of cool games. It's gotten better lately. So Roblox, way back in the day, had this really common like control scheme where when you hold down right click, you can rotate the camera around. And that's really cool because it frees your mouse to do other things in the world. So you were in third person and you could like click on stuff in the environment, but then when you hold down right click, you would orbit your camera around the character, which I thought was really cool. So let's go ahead and recreate that. What we're gonna do is instead of the character adding controller yaw or controller pitch input like this, we're going to make it so that the character's rotation is always just the direction that they're walking in. Direction, rotation. What we can do is we can check orient rotation to movement right here. And now the character will try to point in the direction that they're walking. Cool. We'll also make the rotation rate not be instant. In Roblox, your character would like snap around back in the day. So I'll make that like a 5 and a 5 and compile and save. And now, if I hit play, you can kind of see that the capsule, the capsule's not actually rotating, but the camera's trying to rotate a little bit. That's cool. I'm gonna do a debug arrow. For some reason, we can't seem to modify this arrow and whether or not it points forward or not. But we can add our own arrow, like that, and we'll make this arrow actually have be visible in the game. So no longer hidden in the game. Compile, save, play, and okay. So our arrow continues to point forward, even though we said orient in the direction of movement. We'll figure that out. We'll figure that out in a bit. For now, let's also do the camera rotation. So I'm going to say right mouse button. When the right mouse is pressed, we're going to open a gate. Gates are a cool little concept in just, blueprints, flow control. And when it's released, we'll close the gate. And what passes through the gate is the mouse X input and the mouse Y input. And mouse X. There we go. And actually, we'll do the 2D thing. We'll do mouse X Y, 2D axis. There we go. Cool. What this should do is we want to add rotation, local rotation to the spring arm and the rotation should be, if we break this and we do make rotator, the roll should be on mouse X, and actually the yaw should be on mouse X, and the pitch should be on mouse Y. Let's see what this does. So now, when I hold down right click, I can drag my mouse around and I can do this. Unfortunately, cool as these controls are, oh, I'm already getting a little nauseous, a little difficult to orient myself. And if I keep spinning my mouse in circles, I can actually dramatically change the orientation to the point where we're upside down. So not great. Let's improve that. What we're gonna do is there should never be any how do we do this? Set rotation. We can do sweep. Yeah. We only want to move on the like we only want to rotate around the z axis. We could do add local rotation. That's the problem. So we'll do add global rotation. Add rotation. There we go. World rotation. Because local rotation is local to the arm, and since the arm is rotating every frame, the local space changes. There we go. Okay. There we go. That's better. Because okay, it's a little bit better. Trust me, guys. Trust. Mouse X is working, but mouse whatever this is not working. Mouse Y. So I'm gonna go ahead and put mouse Y on roll, I guess. We'll see what happens. You guys just have to take my word for it about whether or not this feels good or not. I also don't like that. Let's go ahead and let's make this flat to begin with, and let's make the camera point straight in to begin with as well. Keep things a little bit simpler. Yeah, that's really interesting. So
I think you may have to like set it up on like a gimbal.
A gimbal? I don't know what that,
Like you have
don't
like
believe
you
me.
have like an empty object that is the parent of the spring arm, and it acts as just the horizontal
Oh, I see what you're saying. I see what you're saying.
rotation.
And then another one that could be the parent of that, and it's just a vertical rotation. That's a valid point, but
Yeah.
that's more complexity than this should require. We should be able to achieve this strictly strictly doing rotation like this. I think the issues that we're having is that like it very quickly gets out of whack, like out of line on where we're rotating. I think we want to do add rotation. It might be add relative rotation. I'm just going to give this one last try before I temporarily give up on this. Okay, that's actually that's working pretty well. The fact that it doesn't, yeah, that's working. That's working. I just need to plug this into what I originally had and save. There we go. Okay, great. This actually feels great. With my mouse, I can now, there we go. Perfect. Whoop, we passed underneath him, but there we go. I can actually pretty easily with my mouse control where I am with the camera. That's great. That's really great. We can also show the mouse cursor on event begin play. So event begin play. Show mouse cursor. Cursor. We could do set show cursor mouse get mouse position. There's a way to do this. Hidden. So this is another one of those moments. Just feel free to look up documentation. Show mouse cursor UE5, UE4. It doesn't matter. It is set show mouse cursor. That's what I thought. Event. Oh, you got to get the player controller. So the mouse cursor lives on the player controller. So get player controller. Set show cursor. There we go. Just like that. And compile and save. And now, when we play the game, you can still see our mouse, and you can see what I'm doing. I can drag around like this when I want to. And additionally, when I am pressing right click, we should on pressed turn off the mouse cursor, and on released turn the mouse cursor back on. Perfect. Compile, save, great, boom, and now we can drag like that. Cool. Cool, 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 cool. Very nice. Capture or mouse set mouse position. We can also, while this is running, recenter the mouse such that it allows us to drag as much as we want to. Oh, and it's putting us in the, let's put us in the, let's do like 100, because it was putting us at the top right corner. Just pick a random spot on the screen. And now we should be able to, there we go, drag freely, but the moment that I let go, we get our mouse back, and it's like way up here. So drag freely, get it back. Perfect, great, awesome. We are, oh, we're chilling. So now that we have these mouse controls separate, what we can do is we can make like a little top-down shooter, almost like Foxhole, where depending on where our mouse is, we can make our player try to aim in that direction, and maybe like maybe shoot out like a ball or something. How's that? Maybe we are like a portable tank that shoots like artillery rounds. I like that. I like the artillery rounds idea. That might be a good example of some alternative movement here. So let's go ahead and just design a little tank made out of cubes, kind of like last time. So I'm going to go in here and I'm going to do cube, viewport, beautiful. Here is our tank's body, like so, and then maybe another cube that is parented to that and lives on top of it as like the turret, and kind of like that. Turn off the snapping so that we can do some more precise styling right here. There we go. And then we'll put this kind of back here, and then we'll give one more cube, and we'll call this the barrel. Nice. Tank. Excellent. Excellent. So, cool. Cool. Okay. Now, what we can do is we can say when we click, we're gonna pick like a target position. First off, let's try playing the game. So we play the game. Nice. There's our tank. We can move it around. It doesn't really try to. It does try to rotate a little bit. Ooh, it's struggling, and I think that struggle is related to the. Oh my gosh. It's related to the. I want to say the align to movement thing that we checked over here. Let's do orient rotation to movement. If true, rotate the character towards the direction of acceleration using rotation rate. Okay, so rotation rate, we'll probably change these a little bit just to just to see if that was responsible for the glitchiness that we're exhibiting. Can also make sure that these don't have collision. So being cubes, they presumably have collision enabled. Yes, they do. We can make this be, we can turn off the collision of the capsule by going over here to collision presets and making it be it pawn is probably important, but we could do we'll do no collision, and we'll change this to be the pawn collision. So back down here, collision presets, pawn, and this cube can be no collision, and this cube can be no collision as well. So it's just the body of the tank. How's this work now? Oh, she falls right through. And that's because the collision of the capsule was important to the programming of our character. See, this is more of a vehicle, so I can understand why it's not playing nice. At the very least, we can turn off the collision of these other features and see how that behaves. Oh, that's because we started underground, start above ground. A little bit too high, perhaps. Ah, and we're still twitching. It's very unfortunate. It's not at all clear to me why that twitching is occurring. Yeah, not entirely sure about that. Maybe if I try to... Yeah, that's so odd. Very unfortunate. Delete the arrow that we made. The spring arm is fine where it is. It is parented to the capsule component. However, oh, I guess the mesh is what's orienting itself. So it's possible that we'll get better results if we just orient ourselves to the mesh appropriately. Like so, maybe. Let's see. Man. It is really struggling. It's fighting against something. I don't want to waste too much more time on this for now. Oh, those are the fighter jets that just flew over the game. Oh, that's awesome. I'm sorry, guys. The little roar that we just heard outside, a bunch of fighter jets just went over the football game happening at my university here. Okay. Cube. No collision. Can character step on the cube? No, because the character is not part of that. No. 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 Compile and save. Play again. Okay, unironically getting more twitching this time. And it's only when we're walking straight backwards. It's certainly not orienting to the direction of the movement. Gosh. This just gets ickier and ickier. Man. Well, I'll tell you what, the forward direction isn't changing. I have noticed that. Man. This orient to walk thing should be working, and it's not. Orient rotation to movement. Normally, you will want to make sure that other settings are cleared, such as use controller rotation yaw on the character. Use controller yeah, no, we're not doing that. We're not even doing add yaw or anything like that. Controller, anything related to controller. Nope. No. Rotation settings. Very interesting. Ignore base rotation. Interesting. So this is if it wants to rotate with like another object. Uh, I decided to make a tank out of this. We're just gonna I'm gonna get rid of this tank shenanigans. See if it still walks. We twitch. We twitch when we're walking backwards. That is so unfortunate. I have no clue why that twitching is happening, especially given that we've absolutely not done any adjustments to the collision. We just checked that one box. I'm gonna look this up real quick and see what we find. So orient rotation to movement twitching Unreal, and yup, controller rotation yaw. No one else noticed this. Capsule component control rotation yaw on tick event. Some people are complaining about the player component having issues. Camera shaking when moving backwards. Ooh. And it's not an issue with the camera. It's not an issue with the animation. Wow, yeah, people have actually, this is an issue that has gone somewhat unsolved. That's really surprising. I think we might have just found a flaw in Unreal Engine, which disappoints me a little bit, but it is what it is. We can just rotate things ourselves. It's not that big of a deal, guys. All we have to do is set the rotation to be in the direction of the velocity vector. So what we can do is on event tick, we can simply get velocity, get the last update velocity, and we can set actor rotation to be in the direction of velocity, like so, on event tick. And now, there we go. There we go. We can walk left, we can walk right. Now because of the spring arm, now if I just hold down, D or A, it keeps rotating to the right, and that's because yeah, the walk is not, in a global direction. What we actually want is for the actor movement, to be relative not to the actor forward vector or the actor right vector, but to the right vector of the spring arm. So get right vector of the spring arm and get the forward vector of the spring arm. And or perhaps, like you said, a gimbal. We probably want to do a gimbal. So I'll make an arrow, and I'll parent the spring arm to the arrow instead, like so. Spring arm on the arrow, and it will be the arrow that we rotate, not the spring arm. Yeah, this should be better. So arrow get right vector, and then arrow get forward vector. What this is going to do is it's going to keep these vectors consistent with the direction that we're looking, not necessarily the direction that the actor is traveling. Because right now it's relative to the actor direction that they're traveling. Yeah, so that arrow is moving with our character. And what we can do is we can set this arrow to, we don't want it to rotate, so parent Attach, transform, rotation, scale, can lock some of these properties. What we want is for this to we want the forward vector of the arrow. This is making me think for a second, guys. I'm sorry. The spring arm is what's rotating relative to the arrow, but we want when we press W, we want it to move in the screen's direction, and that should be independent of the character direction, but this arrow is always aligned with the screen. Oh god, and it's not easy to separate it out. Make component not rotate. Make component not rotate with parent Unreal. Ignore rotation. Okay, there's a property in the spring arm called inherit yaw that we can disable. Beautiful. Inherit yaw. Nice, just like that. Whoa. Angry. Target must have a connection. Ah, okay, yeah. Get forward vector of the spring arm. Get right vector of the spring arm. Let's try this. So, nice. Okay. So, okay. Ooh. Look at him spin. Doing his best. We press W. He's just walking in circles. That's so funny. That's so interesting. We're seeing some really interesting behavior here. Oh, we're seeing some very intriguing behavior. That's me holding W the entire time. So let's set the rotation to world absolute. World. There we go. That's what I was looking for. Cool. And now, there we go. There we go. There we go. He's walking to the right, back, left, forward, all relative to our spring arm component. Incredible. When we look at him from the top, the whoa. The W has changed. Whoa, okay. Yeah. We're still some issues, but fundamentally that solves our problem. It's this right here, this absolute rotation versus relative rotation. So what we need is for some sort of arrow component here that is absolute and therefore, not attached to anything. Parent the spring arm to that. Arrow will be in world space. And then we can, instead of rotating the spring arm, we can rotate the arrow. So with mouse X, we will rotate the arrow, and with mouse Y, we'll rotate the spring arm. So add relative rotation to the spring arm, add relative rotation to the arrow, like so, not the spring arm. And the make rotator right here is going to pull the yaw from here, and the pitch is coming from there we go. Okay, compile, save, great. A little bit of fooling around, but now the arrow will debug this by visualizing the arrow. Here we go. Hidden in game, compile, save, hit play. The arrow now rotates like that. There we go. And the spring arm rotates up and down. So what I'm going to do is I'm going to recheck the inherit yaw button over here. And now we can use that arrow as our forward direction. So, because now that arrow is pointing in the right direction. So you do arrow right here, get forward vector, get right vector, bang, compile, save, compile and save, there we go, play, and now, oh gosh, did I not? Spring arm is parented to arrow, spring arm is in world rotation still, isn't it? There we go, relative, compile, save, bang. There we go, and now everything works, everything works. Spring arm can go a little too far, but we can fix that later. For now, we have this movement. Incredible, incredible. And we can probably get this guy to aim at our mouse. That's like the next step, is making him aim at the mouse. The movement is done. The next step is making him like shoot at where our mouse is aiming. So what we can do for that, some pretty easy stuff. Let's, we can take all of this, comment it out, be like, yep, this is movement. Now we can say on mouse, on event tick, let's do some other stuff. Let's do get mouse position on viewport, project to world. And this is get player controller. So we're finding where the mouse is in the world. And what we want is really get hit position under mouse. So we want to fire an array out underneath the mouse. Let's do get mouse position, get hit result under cursor. There we go. Get hit result under cursor. That's really what we want. What this is going to tell us is it's going to tell us where the mouse landed. Whenever you see a dark blue thing like this is a struct. It is just like an object with a lot of properties. You can just drag off of it and do break, and you will get all of the properties. So what we're looking for is, what we want to know is where our mouse landed, and then we can do on event tick, we can do a gate, and this gate only opens when we're holding left click. So this is like a fully automatic like gun or something. So click, or left mouse button, excuse me. So pressed, open, released, close, and through that gate, line trace by channel. So line traces are how you fire out lines. These are a very common tool. And the start location is going to be where our character is, which I'm going to say is the position of the arrow, and it's going to end underneath our mouse. And I'm going to debug it for a persistent amount of time. Compile, save, and play. And now, check this out. We shot some bullets. Geek, gra. Skibidoo papa. Like, so our character is like shooting, presumably. That's what this is. We're finding the hit result under the mouse cursor, and on event tick, we're shooting out some rays. Now what we can do is we can place explosions under those rays. We can add a delay so that they fire at a specific rate. We can check what object we hit, and based on what object we hit, apply some damage or something. And so that's the next direction that I was going to go in. I'm going to take a little break here. I really zoned out for a minute there with the yaw rotation stuff. Movement can be a bit of a headache, but we figured it out eventually. What are you guys thinking? Any thoughts, any concerns now that we can shoot with our character here? Can do a scroll wheel to make him zoom in. I'm going to try to demonstrate that you can do different types of damage to different objects by implementing a damage interface. and be like, oh, tree implements damage interface, explosive barrel implements damage interface, and then trees only take damage of type fire, and explosive barrels take, I don't know, kinetic damage. That's the next step that I was going to do. But in the meantime, what are we thinking? Intrigue, concerns. I know they got really slow for a minute. I'm sorry. But we're moving again. Thoughts?
I kind of got behind, but I'm gonna watch the VOD to catch myself back up.
You can take a second right now if you want. Can I? Do you want to share your screen? Let's walk through a little bit of this.
Oh no, I'm pretty far behind.
Okay.
I'll be fine.
Okay.
I'll be fine.
Most of the
Yeah.
stuff that I wasted time doing was a bit of dilly dallying in the just not not able to orient the camera correctly. But we're there now. I feel you. Okay. Well, in any case, yeah, we can also do ricochets and stuff of these like so-called bullets here. Yeah. Cool. Okay. Line trace by channel, trace color. All right. So the next step here, I would say, is implementing this damage stuff. The object that we hit, right? If we break the hit result, we get one of these. We hit some sort of actor. If actor implements an interface, let's say the interface is like a damage interface, we can then do things to it regarding that. So without actually casting to a specific type. So let's say we have like a tree and an explosive barrel. I'm going to go ahead and make a tree object real quick. It's going to be an actor, and I'm going to call this tree. And tree is going to have it's gonna be the world's most accurate tree right here. There we go. That's the trunk, and then this right here is the top of the tree. Yeah, that is a tree and a half, ladies and gentlemen. Just gonna do a little bit of this, a little bit of that, a little bit of that. Yeah, that's basically a tree. Okay. This tree is made up of a bunch of cubes. Just like that. And I'm going to give them all a material. So I'm going to just kind of extend some of the knowledge that we did from the materials last time. I'm going to make a material, and I'm going to call this material master material. Master material. And master material is going to have a couple of parameters. So I'm going to do a color value. First things first, I'm going to define a parameter called is damaged, or damage amount, right? So damage amount is going to go from 0 to 1. And based on that damage amount, we're going to go from being whatever color we want to be. Let's say we're normally, let's do convert to parameter, usual color, like so. The usual color is going to be pink, just for debug purposes. But when we're damaged, we're going to change our color to red, like so, red. That's pink-ish. Well, actually, sorry, that's because the damaged amount is set to 0. And additionally, we're going to set our emissive to be the sine of time multiplied by the damaged amount multiplied with some sort of color. So this times that same damaged color emissive. Perfect. So if we're not damaged at all, nothing happens. Nothing happens. But if we are damaged, bad things happen. And we start flashing red. Sick. So let's see what happens when we make this 1. Now we're damaged. This is what a damaged object will look like. It'll flash like this. And you know what, honestly, I kind of wanted to flash a little bit more brightly, so I'm going to multiply that by like 10, and then that should make it really glow pretty hard. There we go. Awesome. Great stuff. Great stuff. So there's our master material. I'm going to make some instances of it. I'm going to call this tree green, and I'm going to call this other instance tree brown. And back in our tree, I am going to assign tree brown there, and I'm going to assign tree green and tree green to the different cubes. Tree green, I'm going to change the damaged amount to 0, the default value, and I'm going to set the color to be a nice green color. And I'm going to drag our tree in like that. Whoa, moving a little too fast for my tastes. There we go. Here's a tree. And then tree brown is also going to have the damage set to 0 and the color set to be brown. I said brown. There we go. A little bit better. What color are trees anyways? I need to touch more grass. More red. There we go. That's a little bit more brown. Nice. Save. Good stuff. I'm also gonna go back and make this material less shiny because I don't like it when it's all shiny. There we go. Completely rough. Fully diffuse. Nice, there's our tree. Okay, alright. We can actually, there's a foliage mode that lets us really quickly paint a lot of these things. So for instance, we can just go in here and just be like foliage. It does expect static meshes, but I believe there's a way to paint in blueprints. So that's kind of cool. Foliage, actor foliage, new actor foliage, actor class, tree, save, back, and then foliage. Ooh, doesn't like that. Static mesh only. No. Yeah, there's a way to do this. There's a way to do this. Foliage. Actor foliage is a foliage type that will place blueprint active. Cost of painting this foliage is the same as adding actors into the scene. I thought so. Yeah, new actor foliage doesn't really want me to do that. That's great. That's great. Well, we'll mess around with that at another time. Normally I think you're supposed to be able to drag this in here, but it clearly does not want me to right now, so I'm not gonna bother with that. Back to the world. Let's just drop a couple of these trees in. There's another one. Here's another one. There we go. Just duplicating them by holding Alt and placing them around. Nice. Got a little forest to ourselves. Good stuff. Now, let's also go to blueprints and let's make a interface. Blueprint interface. I'm going to call this damage interface. And damage interface is going to have a function called take damage. Compile and save. And I'm also going to make under blueprint an enumerator. And I'm going to call this damage types. And there will be 2 damage types. There will be fire damage, description, it burns, I don't know. And then another one called kinetic damage. And this will be ouch. Oh, why not? Back to damage interface. we can have this function, compile and save, take an input, and the input will be a integer, presumably from 0 to 100. That will be how much damage. So we're going to call this damage amount. And then the output is going to, no, we don't necessarily need an output, sorry. The other input is going to be damage type. So damage and damage type. Oh, that's not what we, where's our enum? Sorry, enum. We just made this thing. What did I name it? Let me just go back and find it. Oh, excuse me. Damage types. Okay, back to the damage interface. Damage types. There it is. This is the one that we just made. Damage type. Cool. Compile, save. Great stuff. And now, back to our tree. Go to the tree over here and click class settings. And under class settings, you can say interfaces, implements, damage. And now if I click compile, it should get a little angry at me, but oh yeah, here's take damage. So if I double click this, I now have to implement the event take damage. So I'm gonna do print string. I am a tree and I took, and I'm gonna do a little string builder class here. Build string with an integer, and so the prefix is going to be I am a tree and I took damage amount damage of the variety, and the damage type will be string build string the variety damage type literal enum, okay, byte to enum damage types, utilities enum, can do switch on damage types. Yeah. Okay, sorry. Switch, no, to string. Like we want to turn this into a string essentially. Enum to string. Great, that's a thing. Append to prefix. Okay, concatenate. Concatenate. Append to be just like that. Compile, save, great. So we have these trees, we have our character, the trees implement an interface, the interface has a function, the function is using the enumerator that we just came up with called damage types to describe either kinetic or fire damage. And now what we want is these trees to change their materials. So what I'm going to do is I'm going to do on event begin play, create material instance, a dynamic material instance. And the parent material is going to be this master material right here. And we're going to get back a material instance. I'm going to promote this to variable, and this is going to be the variable that we're storing locally called material instance. So this is the one it's created at runtime. So this is just a material that is created the second that we start playing our game. For each tree, it's just an instance of the master material. And because it's for each tree, we can control them independently. So now we want to set parameter. So let's set the vector parameter value of set scalar parameter value. Let's set the scalar parameter value, and we got to make sure we get the name right. So this is going to be damage amount. Let's also make a variable called health for the tree. So this is going to be an integer. I'm going to make it health. The default value is going to be 100. Excellent. All right. So on event take damage, set health to get health minus however much damage we just took. So health is equal to health minus damage. And on event begin play, we have the material instance. We set the damage value to 0. Parameter name, we got to make sure that this is exactly right. It's a string. We got to pull it over. What did we name it over here? We named it damaged amount. So I'm just going to copy that, paste it in here like that. Excellent. Get parameters. There's a nicer way to do this, right? Like get material parameters. Yeah, no, not quite. That's okay. There's got to be a nicer way to do that, but in any case, the damage by default is going to be 0. And then every time that we take damage, we're going to set the value of that damage value in the material, damaged amount. We're going to update it to be this integer divided by 100. So integer divide by 100. Let's make a literal float. Make literal float. Okay. Make float. This should force this to, yeah, let's see. Yeah, okay. Compile, save. Cool. To float. Let's make sure that this happens in float math. So it's 100.0 divided by 100.0. And okay, now we don't have a way to take damage on the trees yet. So back to the character. This is when we hit something with our gun. If the object implements the damage interface that we just made, switch or flip if branch. That's what I was looking for. If we hit it and it does implement that interface, true, then we're simply going to call damage take damage on the take damage interface, and we're going to call a damage amount of 20 of the type fire damage on anything. So we have like a flamethrower, I guess. I don't know. All right, let's do this. Oh, those are tiny trees. Oh, I took 20 damage of the variety fire damage. They're getting lit up. Oh god. The trees are heavily injured. However, they're not changing their colors. They're not flashing with orange. So we'll debug that in a second. But we're hurting them. They're feeling the pain. Very good. I hate trees. No, I love trees. Okay, so cool. Making some progress here. Yeah, back to the tree. Obviously something's not right here on set scalar parameter value of the material instance, which is coming from master material. Probably because we're not setting their material. We have to set material to be the parameter. There we go. The one that we just made. That's why they were being set. Like we made a new material, but it was just sitting around in memory. We did not keep it around. There we go. So bang, bang, compile, save. Oh no, I'm angry. Let's do 1. Let's do 2, and let's make sure that or actually, oh no, sorry. It's not 1 and 2. This element index is saying which slot is it. Is it slot 1, 2, 3, 4, if there were multiple slots. But these cube objects that we're using are objects that come with the game engine, and they have a single slot. So that's why we're not going to do, you know, zeros and ones and all that. Back to the tree, back to the event graph. These should be 0, cube 2, cube 1. They're gonna be purple to begin with, but this should work. Yup, purple. I shoot them. Oh, and now he's flashing. Look at that. Boop, boop. You're hurt. Maybe if I can click on this guy really fast. Now he's only taken a tiny bit of damage. What we could do is we could say based on the damage, they could blink faster. Decrease the period of the sine wave. There we go. Now they're all fully damaged. Awesome. Awesome. Very cool. But now, what if we had an explosive barrel? So we could pretty much duplicate the tree. And we'll call this barrel in all caps because I can. And all I'm going to do here is I'm going to delete these 2 cubes, and explosive barrels, as we all know, are just a single vertical red cube. So there we go. It's failing to compile. That's because of these guys. Those materials no longer, or those cubes no longer exist. Compile and save. And barrels will, let's say I am a barrel. They implement the same interface, the same damage interface, but maybe barrels implemented differently. Maybe barrels, in the event that the damage type, you know, switch on damage types, if the damage type is kinetic damage, do all of this stuff. But if it's fire damage, print explosive barrels are immune to fire. Mwahahaha. Compile and save, and then we don't have any barrels in our world. Here's a barrel. Explosive barrels are immune to fire because we're sending out fire damage, but explosive barrels are immune to fire, so they don't do anything to their materials. But the trees, they all take fire damage. Nice. Very nice. Cool. Guys, I hope that this is interesting. Today we learned about interfaces and blueprint to blueprint communication using interfaces and adjusting the properties of a material. I know that this hasn't been the most aesthetic demonstration, but the principles here can be used to do a lot of cool effects. We could, you know, if you sit down and actually like don't make your barrels look like cubes like this, and maybe make a little particle system so that they blow up, easy. Like you can make some really nice effects very easily with that. So back to comms. Fire tree, yep. Let's make that the channel status, William. I like that. There we go. Set status. Perfect. Cool. Damage interfaces. What else? There is such a thing as a level blueprint. If you go, where is it? I think it's you have to click on the level itself, and since I haven't saved the levels, save. Level, no, it's somewhere in here. Open level blueprint. The level blueprint has very easy access to anything that already exists in the level world. So it makes it very easy to, you know, if you were making a storytelling game, like a campaign game, and you're walking through the environment. Let's look at Crisis 3. Welcome to the Jungle. So here's one of my favorite games of all time. Very inspiring game, in my opinion. Crysis 3. It's a campaign game. Let's skip ahead a little bit. Here's... Oh, wow. Is that Who is that? Okay, cool. Google Lens. Good stuff. So here's Crysis 3 being played. Crysis 3 is a big part of why I got into computer graphics. Love this game. So this guy's walking around in this like park environment, right? And when he gets to a certain point, he gets to this like checkpoint here. You're gonna see in a second. Oh my god, I think my roommates just dropped some large object. Watch, when he walks up to this door, it triggers this event. You know, this guy falls over, some things happen sequentially. He presses F, it opens the door. The state of the level has changed now. The door is open. The AI dude that's following him pathfinds up here. And then once he gets up here, it triggers cinematic sequence. Ooh, big missile tower shooting at like aliens in the grass. This game has stunning graphics, even for like still does. What, 2012, 2016, something like that. Actually insane. So this cinematic sequence plays and then the game continues. How would you do that in Unreal Engine? You would do that with a level blueprint. The level blueprint is really good for handling these sort of cinematic situations. So over here on the left, under Place Actors, and if you don't see that, by the way, you just have to go to Window and check this Place Actors thing to get this nice quick panel of pre-made actors. And get a trigger volume, trigger box, and we could put this trigger box, like over here. Why not? Maybe over here. I'll make it visible in game so that we can actually see where it is and walk into it. Please, rendering, visible, actor hidden in game. Ugh, okay, hidden in game. There we go. Couldn't see the rendering panel. And we can name this something. We can name it trigger 1. And in the level blueprint over here, open level blueprint, we can actually make this like a separate tab, kind of like this. It's very easy to just boop, boop, like that. And now you have a reference to that object. There's no, you can't do this anywhere else. Only in the level blueprint can you so conveniently grab objects that were already in your world to begin with and work with them. So we can say trigger 1 on overlap custom event. And I believe what this does is as long as on event begin play we do this, we're saying on event begin play, take trigger 1 and take its function, the function called on actor begin overlap, which just means some other actor has begun overlapping with it, and bind that function to this one over here so that it gets called. Whenever it gets called on trigger 1, call it here. And then we can do print string and get name, get display name. No, not get display name. Get actor name. Get actor. Get ID. Oh god. Get actor GUID. There's a hold on. It might be get name. Rename. Get assets. Ancestors. Rename assets. Clear timer. Get object name. That sounds right. Boop. Compile, save. And now, when we walk into that with our character, there we go. Trigger box. Trigger box. Trigger box. Trigger box. Trigger box. So you can set off events in your environment. You can set off a cinematic sequence. You can just build a level that has like traps and stuff. So if you were making a platformer in Unreal Engine, say you were making like a 2D platformer and you had a bunch of levels, you'd probably be using the level blueprint semi-frequently for really exceptional features of those levels. But for the most part, you probably want to keep the level blueprint free of functionality because it's not easily reusable across different levels. So if you had a platformer that has like a like a flag or something that's your checkpoint, that checkpoint flag shouldn't be something that you recreate every time using trigger boxes. It should be its own separate object. That way you can reuse it on any level that you go to. Like, design around reusability. But if you are making Crisis 3 or you're making, I don't know, some just really giant level and it's all done in one level, like, yeah, there's going to be situations where there's just very specific functionality that you might want to build into the level blueprint, and the level blueprint makes it very easy for quick like prototyping like that. But in general, it's better to organize things under their own functions. I hope that makes sense. Yeah, okay, this is all right. Little break. It's like 7:43. We've gone on for about an hour and a half. Honestly, I think this is enough content for today. I moved really quickly through the end of it. The beginning of it, I went a little too slowly because of my tomfoolery trying to get the camera to point in the right direction. But we're done with that now. So yeah, what are we thinking, guys? Any questions, concerns? I'm gonna call it. I think we're done there. Can I elaborate on anything? Do interfaces make sense, you guys? They're like a collection of functions that you can say multiple objects implement, and then you can very easily check if an object implements an interface without needing to cast to it. So this solves the issue. I'm like, hey guys, you guys have any questions? And then I come up with like questions that you should ask and try to answer them. But if we were trying to do this the way that I taught you last time with casting, we would have to do cast to tree. And then, oh, it's not a tree? Okay, then cast to barrel. And then, oh, it's not a barrel? Okay, let me check what else it is. Could it be a coin? Could it be another character? It could be like a million different things. So this casting technique of cast to it, and then once you're confident that it's a tree, call some function on the tree, is not the way to solve this problem. Like, you will have big issues. Instead, you just fire off an event on that object to its interface, and you trust that that object has implemented that interface. Because if the object claims to implement the interface, then you know that it has this function here, and different objects might have different implementations for this function, but this functionality exists. So the tree says, oh my god, I'm a tree and I'm on fire. The barrel says, I'm immune to fire damage, get wrecked. But yeah, it varies. You can make different objects have different implementations. It's also event dispatchers, which we still haven't gotten to, but I'm gonna, I think, do at a later point in time. But event dispatchers are pretty awesome. You can.
Hey, gotta go, but thanks for the talks.
Yeah, absolutely. Was that Prez or Mike?
Oh, Mike, yeah.
Mike, Godspeed, Mike. See you, man.
Yeah, I'll watch the rest of this.
There's not much left. I'm not going to go over anything else. I'm not going to do event dispatchers today. We'll do that at another time. I think they're perhaps the last core thing that you really need to understand about Unreal. Like, everything else is pretty much there. So
thank you.
Yeah. Yeah, try to organize this a little bit. One thing we could do is we could refactor this a bit into functions, right? We could make a function that's called update tree materials. Pull all of this into one nice node called update tree, or set tree materials, or just in general make ourselves some nice helper functions that clean up our code, quote unquote. Yeah. Okay, no comments. I'm gonna end the recording here, but it's been fun, you guys. I hope this was somewhat insightful. We went really fast, but we got third-person controls, third-person movement that's relative to the camera. We have the ability to shoot our pink debug line traces that you can replace with bullets on your own time if you want to. Hit the tree, set the tree on fire. make it take a lot of damage. See, when we only hit it once, nothing happens. It's flashing, but very subtly. But we hit it enough times, the flashing gets brighter. So, boop. Very subtle flashing. Crank it up. Lots of flashing. And lots of flashing. The barrel says, nope, I'm immune. Yeah. And the trigger volume reacts by printing out its name. We could also make it print out our name. Probably more interesting that way. Yeah. Yeah. That is that. That's what we've accomplished today. Very good. Very good. Cool. Character movement component has all this pre-made functionality for you, like walking and sliding and running and jumping, and wall running. Maybe I don't know if it has wall running, but you can turn it into having some wall running features. It's very nice. It's very powerful. It also has netcode related stuff built into it, so that's kind of cool. Yeah. Okay. All right. I'm gonna end this. Thanks for coming, guys.
Yeah, thanks for hosting.
Yeah. See ya. All right.